Hello, it's Mrs. Metzler. Miss you all. Seniors, this is your last set of notes in pre-calc. Woohoo! The rest of you, we have, it is actually our last topic, but we will do a couple more example videos. All right, so let's get to it. Here's the notes I uploaded in Focus. I have my unit circle next to me, and here we go. So, we are finding all the solutions of these equations from 0 to 2 pi. No matter what your book says or what the directions say, we're going to always only find them from 0 to 2 pi. It just makes it easier. Okay, and so let's look at our first equation. What if you had this equation? What if you had the equation 2x minus 1 equals 0? How would you solve that? You'd add 1 to both sides and divide by 2. So it's going to work the same way in this equation. We are solving for sine x. So we do the same thing. Add 1 to both sides and divide by 2. So we get sine x equals 1/2. So now what you have to do is look at your unit circle. You have to think, is sine your x value or your y value? Sine is your y value. And so you look at the defined points on your unit circle where, excuse me, where does y equal 1/2? So I'm looking at my unit circle. I'm just starting at 0 and going around. Oh, I see it pi over 6. That y value is 1/2. So x does equal pi over 6. Let's keep looking, see if there's any more. Dun, 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 going around. I'm at 5 pi over 6. I see it equals to half there as well. Going around. At 7 pi over 6 equals negative 1/2. We're not looking for negative 1/2, so that won't work. And then the same thing at 11 pi over 6. It's at negative 1/2. That will not work. So that's our solution. X equals pi over 6 and 5 pi over 6. Okay. All right, let's go on to the next one. We're solving here, in this case, for tangent x. Okay, so tangent x, what do? We take the 1 to the other side, so it would be negative 1, and then we're going to divide by square root of 3. Now, we could leave it like that. Doesn't make a difference. If you want to solve it properly, that's fine. You know, like get the square root at the bottom, we would get something like negative square root of 3 over 3. So this one's not quite as pretty as sine, because remember, for tangent, you do have to do some manipulating. So let's recall, tangent is y over x, all right? So it's same thing. Let's look at our points. Let's just start at pi over 6 and see what happens. So y over x. So at pi over 6, my y is 1/2. And my x is square root of 3 over 2. I'm going to do keep, change, flip. It's already divided. So times 2 over square root of 3. I just flipped it. So this would be gone, this would be gone. I'd get something like 1 over square root of 3. Now look back up here at this guy right here. Close, but we need negative. So what does that tell you? That tells you that that point, pi over 6, which is square root of 3 over 2 and 1/2, would work, except we need it negative. So let's go around and find where we can find where it's negative. So I see over at, yeah, it's getting squishy. Look at 5 pi over 6. If we divide y by x there, we would get negative 1 over 3. Let's just do it. I want to just talk and tell. So it'd be the same as this, right? We'd have 1/2 times negative 2 over square root of 3. So we'd get the same thing. Okay, I guess we didn't need to show that. So we know 5 pi over 6 will work. Let's find another point where it's the same coordinates, square root of 3 over 2 and 1/2. So 7 pi over 6. Negative square root of 3 over 2 and negative 1/2. Well, what's a negative divided by a negative? A positive. That won't work. Keep going. Here we get to 11 pi over 6. At 11 pi over 6, I have square root of 3 over 2 and negative 1/2. Okay, sorry, I had to pause for a second. So we were at 11 pi over 6. That is the same point. Square root of 3 over 2 and negative 1/2. So 11 pi over 6 would also be a solution for this equation. Okay, let's move on. So here we are solving for secant. We have secant squared, so that just creates a little bit more of a job for us to do. So we take the negative 2 over. So then we have secant squared x equals 2. How would you solve something for x squared? You take the square root, and what's the other little piece you have to remember? Plus or minus the square root of 2. Okay? So now our job is to find where does secant equal plus or minus the square root of 2. Remember, secant is like cosine, and cosine is the x value. So secant would be 1 over x. Okay? 1 over x. So we're only looking at our x value. So let's just start at pi over 6. Do we think, so remember, what does this mean? 1 divided by x. So essentially, you're just going to flip the x fraction. Okay? So let's start at pi over 6. Our x value is square root of 3 over 2. Do we think if we flip that, we're ever going to get just the square root of 2? Probably not. Let's try pi over 4. Square root of 2 over 2. So that means you're going to have 1 times 2 over the square root of 2. How about if we simplify that, square root of 2 over 2? Oh, we think we're going to get there? We would have what? 2 square roots of 2 over 2. Oh, and look, those 2's would cancel, so that point works. Now, think about the plus and minus part again. So that means all the points that have the square root of 2 over 2 as their exact value will solve this equation. So we were just at pi over 4. We know that one will work. Our next one that has square root of 2 over 2 or negative square root of 2 over 2 is 3 pi over 4. Our next point, negative square root of 2 over 2 is 5 pi over 4. And moving right along, the next one is 7 pi over 4. So those are the solutions for this one. Okay. Alrighty. Next one, we have tangent x plus square root of 3, cosine x plus 2. I ask you this question. What if you had x plus 3 and x minus 2 equals 0? How would you solve that question? Right? You just set each of those equal to 0. So you do the same thing here. We say tangent x plus square root of 3 equals 0, and cosine x plus 2 equals 0. And remember, in this case, you're just solving for tangent x. In this case, you're solving for cosine x. And you're actually solving them like separate from each other, not the same. Okay, so here we get what? Tangent x equals negative square root of 3. So let's just work on that one first. So if you recall from example 2, we know that tangent is y over x. So we did one up there. It doesn't matter. Let's do it again. If we start at pi over 6, we're going to get 1/2 times 2 over the square root of 3. So that's almost the opposite of what we want, right? I think that's that's what we were looking for in the earlier example. So what happens if, so we don't want that. That's 1 over the square root of 3. We want just square root of 3, or negative square root of 3, obviously. How about if we go to pi over 4? What happens when you divide square root of 2 over 2 by the square root of 2 over 2? You're going to get 1. So let's try pi over 3. So we're done with this. Pi over 3, we would have the square root of 3 over 2 times 2 over 1. Aha! That's it. In this case, we would get the square root of 3. So that's the point we want. Maybe not necessarily pi over 3, because we need a negative square root of 3. But that's the point we want, meaning 1/2. And then, for your y value, square root of 3 over 2. So let's go around the circle and find where those other values are. I am not keeping this very neat, sorry. All right, so we don't want pi over 3. The next place where I see that point occurs, that point, I mean 1/2 square root of 3 over 2, is at 2 pi over 3, and it has a negative. So x would equal 2 pi over 3. Yay! Let's find that point again. I find that point again at 4 pi over 3. However, the x and the y are both negative. We can't have that. Okay, then we move on, and then the next one is at 5 pi over 3, and that one will work. Okay, so that's the solution for the tangent. Like I said, they're separate from each other. That's okay. Let's work on the cosine. So cosine x equals -2. Find a place on the unit circle where that's true. Did you find one? Nope, because there isn't one. So that part of the equation is simply no solution, and that's okay. All right, next one. So example 5, you're going to want to look at like a factoring, exactly like a factoring problem. 4x squared minus 4x plus 1. Okay, so if you would factor that out, let's draw a line here. If you would factor that out, you'd have something like what? 2x minus 1 and 2x minus 1. But we don't just have x, we have cosine. So wherever you see an x, you just put a cosine. So you'd have 2 cosine x minus 1 equals 0. Obviously, you're going to get the same thing twice, so we don't need to write it twice. So you'd get what? Cosine x equals, move to 1 over positive 1 over 2. Okay. Find on your, cosine is your x value. Find on your unit circle, where does cosine equal 1/2? X value, I see it equals that at pi over 3. Not 2 pi over 3, that's -1/2. Not 4 pi over 3, that's -1/2. And 5 pi over 3, it's positive 1/2. Okay? And it doesn't matter that it's repeated twice. A value is a value. All right, last one. A little different. You're going to substitute. You can't solve unless they're all the same trig function. So we know something about sine squared. We know sine squared is 1 minus cosine squared. So you just make that substitution. You have to turn them all into the same trig function. And then just combine like junk. So which way do we want to go? And we'll take the -1 over. -1 over here, and we'll take the 2 cosine squared to the other side. So just putting everything all together. Manipulating. Nope. So no solution. Good luck. I posted the assignments. Text me, call me, email me.